In this video, we're going to be taking a look at the Bambu Lab A1 with the AMS Lite system, and we're going through everything from the unboxing through the setup all the way to a bunch of example prints. And I tried to select some designs here that would best demonstrate the ability of the AMS Lite system, as well as how to efficiently use it alongside the Bambu Studio Slicer. And if you're not already familiar with the A1, it's the larger of the two bed slingers from Bambu Lab. So they do have a smaller one called the A1 Mini. This one is larger. It's got the 256 by 256 by 256 millimeters tall build volume, and that's the same as the P1 and X1 series. But of course, with the A1, you don't get the enclosure, no core XY motion system, but you do get a lot of the modern offerings of a 3D printer nowadays. So you'll get Wi-Fi connectivity, touchscreen. You'll also get connectivity to their Bambu Handy app, as well as an onboard camera that can produce time-lapse videos. And this machine can be purchased with or without the multi-material AMS Lite system. With that out of the way, we've got a lot to get through in this video, so let's not waste any more time and let's get started. As always, we'll begin here with the unboxing, and if you've ordered the A1 combo, everything comes in a single well-packaged box. When you first open the box, there are some stickers on the insides of the flaps that recommend that you lift the unit out using the plastic bag. With the package up on the table, we can now start deconstructing the many layers of this A1 combo kit. Right up the top, you'll find the flex plate along with the instruction manual. Put that aside for now. And as we remove these sides, we can now start to take a look at what's on top. In the top layer, it looks like we got pieces of the AMS system, as well as the accessory kit. They've also included the boat toy kit, as well as the filament swatches. So we'll remove that top layer. We'll also put that aside. Beneath that, more of the AMS system. Put that aside. We'll get to that in a minute. As I first want to remove all of the components of the printer itself, you'll find the gantry here on top and the base on the bottom. Everything here was extremely well packaged, so I have absolutely zero concerns that any of this will be damaged. As part of the included accessories, there is the Bambu filament swatch kit, and I've got something special planned for this once we get started printing, so be sure to keep watching. But it's a nice kit here that includes various samples of their different colors and materials, and they're all nicely labeled. Then we've got the tool and hardware kit, and inside of here you'll find various tools needed to assemble and maintain your Bambu Lab A1. There's also all of the necessary hardware to get the A1 assembled. We'll get to that also in a minute. And all of the bags are conveniently labeled. Now we can get started on the assembly, and we'll tackle the easiest thing first, and that will be to install the flex plate. It's made of spring steel, and there are magnets on the base, so you can just push the back in towards those locating tabs, and the magnets will take care of the rest. Now we can flip the base onto its side, and you'll see on the bottom there are 4 red color-coded screws. These screws held the print bed carriage in place during shipping, and we'll need to remove these to release the print bed. The color coding is a thoughtful touch to easily identify which screws to remove, and once you're finished, you can put the base right side up. We'll grab the gantry, we'll release the wire harness from the bottom, then we can pick up the base and very carefully maneuver it in through the gantry on an angle, and then we can put it down flat, where there are features to help you locate the base with respect to the gantry. Then you can grab your side cutters and start to cut away all of the zip ties and remove the various packaging that held the components in place during shipping. Once you've finished removing all of that packaging, you can take the entire unit and turn it around. At the back of the machine, there is a plastic access panel that can be lifted and removed to expose the linear guides that the print bed rides on, as well as a bunch of green color-coded holes for the fasteners labeled for base housing. These fasteners will secure the entire frame together, and again, all of the holes are very conveniently color-coded green, so they're very easy to identify. When you've completed all the fasteners at the back, you can manually push the print bed towards the back of the printer, exposing more green color-coded holes at the front, and you'll want to complete these last two before again moving the print bed towards the front of the printer and then replacing that plastic access panel at the back. After that, we can bring the machine over to the edge of a table and flip it onto its back. Now, be careful when doing this because it will want to fall off the table. I found that using a 1 kilogram roll of spool at the top of the frame will help balance it out while you work on the bottom. You can grab the wire harness, and at one end of the harness, it looks like a USB-C style connector, and that is going to get inserted into this slot here on the right-hand side of the bottom of the frame. Then we have to complete a few more connections with these JST connectors, and these are all color-coded as well, so you can't mess it up. There's also an integrated single screw on this connector, and we can tighten that down and lock everything into place so it won't go anywhere. At the bottom of the base, there is one final connector that's taped up. It's color-coded yellow, and this takes care of the Z motor. There's this one wire routing provision at the bottom of the frame that we can push this cable into. Then there is another one that you may be able to pull apart with your fingers. I used a flathead screwdriver because I couldn't get it apart, and it's like a little flap door. The cable can get routed under that flap. You can complete the connection. Then you can simply snap the flap back shut. Be careful not to pinch the cable, but it should shut, and we're done at the bottom of the printer. In the foam panel with many of the AMS Lite parts, you'll find the purge wiper. You can remove that from the packaging, and we can install it on the left-hand side of the machine. It has a dovetail-like feature that slips into this bracket here, and there'll be a single screw in the package called for purge wiper, and that will secure it into place. Once you've tightened that final screw down, that completes the assembly of the printer itself, and we can move on to the AMS Lite system. First, we'll assemble the AMS body onto the stand, and you'll want to make sure that you're putting it on the right way, so the cable is going to face this side of the stand. There will be 4 screws to hold the body to the stand, 2 on each side. The bag is labeled for AMS stand, and we'll insert these screws on the right-hand side, and then we'll repeat the same process on the left-hand side. Next, we've got the rotary spool holders, and you can see the pegs on either side of the body. They are colored green and yellow, and the spool holders also have a color-matched green and yellow label on them. Simply match the colors together, and you should be able to push the filament spool holder onto those pegs. You may have to rotate them around a few times to get them to click in, but once you line them up properly, you'll get that satisfying click. Then you can cut away more of the zip ties and packaging, and we'll address the PTFE tubes. Holding the tubes in your hand, you'll notice that there is a total of 4 of them, 2 of which are longer, 2 are shorter. The 2 short tubes go into ports 1 and 2 of the AMS system, and that's on the left-hand side, and the 2 longer tubes are intended to go into ports 3 and 4 on the right-hand side of the AMS Lite system. The opposite ends of those 4 tubes get inserted into the toolhead filament hub. When you're done, it should look something like this, and in the PTFE tube organizer, you'll notice that there's one more slot open, and it turns out that the cable coming off of the print head is the same diameter as the PTFE tube, and you can put that into the tube organizer, and this will keep that cable from flopping around and potentially interfering with the print head moving. Now that we've got everything taken care of at the front of the machine, we'll move back to the rear, grab the cable from the AMS Lite system, plug it into the port at the back of the printer, and we'll finally plug in our AC power and power up our printer. When powering up your A1 for the first time, you'll be greeted with the start screen. You'll select your language, select your region, and then connect to your Wi-Fi network. Now this is where I ran into my first problem because I have a Google Nest Wi-Fi system which I believe switches between 2.4 and 5 gigahertz, and the A1 seems to be strictly looking for a 2.4 gigahertz network, so I had to hotspot it from my phone. The next issue I ran into was when trying to use the QR code to download and set up the Bambu Handy app. It seems to want to send you to the Chinese page despite having selected North America as my region. So I ended up going right to the Google Play Store instead of using that QR code, and that solved my problem. Perhaps in the future, Bambu Lab can tailor the QR code to the region that you select upon setup. Then, after agreeing to a bunch of terms and conditions, we can begin the self-calibration process. You'll want to leave all of the checkboxes checked because, of course, this is the first time we're starting our printer and none of these calibration processes have been run before. If this is your first 3D printer, don't be alarmed. When the machine starts shaking pretty violently, you'll really want to put your 3D printer on a very secure table or base because an unstable surface could contribute to poor print quality in the future. The A1 will then finally probe and measure the print bed surface and you're ready to go. But you might get hit with some sort of hints here to lubricate your X or Y axis, or perhaps even do a firmware update. In my case, I was prompted to lubricate the Y-axis, so I had to remove the back access panel again. I cleaned off the linear guide surfaces just with a clean cloth, and then included with the Bambu A1 accessory kit is some lubricant, which is appropriate for the Y-axis, and it's in the green tube. Put a few dabs of that on the left and right rails. We can move the print bed to the back of the machine and make sure we get the front. And then we can move the print bed back and forth a few times to work in that lubricant. The next step is to get some filament loaded up into the AMS Lite system, and Bambu Lab was kind enough to send me a nice variety of their PLA filament in various colors and styles, such as marble, silk, and just basic colors as well. Loading filament into the AMS system is very simple. The filament gets inserted through the bottom and you'll find these yellow buttons that you can push up on to release the tension in the drive mechanism. So you'll want to begin by grabbing your roll of filament and cutting off the end with the piece of tape. I personally like to cut my filament on a 45-degree angle so that it should feed nicely into the drive mechanism and through the PTFE tube. Make sure you've got the filament routed down and upwards into the port at the bottom of the AMS system. Then you can push that button up, start to feed the filament in, and release the button, and the AMS system will take over. It will automatically load in the appropriate length of filament, and the RFID tags on the Bambu branded filament can be read by the AMS system, and on the screen you'll see the material type and the color appear. I really love this level of automation. Now if you guys don't have Bambu branded filament, not to worry. Later in the video, we'll walk through an example of loading in another brand and editing that material on the screen. And finally, before we get started, don't forget to remove the camera lens protector on the right hand side of the gantry. Now to get ready for our first print, you'll want to head over to Bambu Lab's website and you'll need to download Bambu Studio. Once you've got Bambu Studio installed and you fire it up for the first time, you'll be greeted with another welcome screen where you'll be prompted to select your region and be asked if you want to join the Customer Experience Improvement Program. Then you can select your machine. In this case, we've got the A1 with the 0.4mm nozzle, but if you happen to own other printers, it does support other models from different brands. So you could essentially migrate all of your slicing into Bambu Studio. After that, we can select more presets, and many of them being the various filament types. So I'm just going to select the A1 printer and I'll choose all of the filaments and I'll import all of those settings. Then I'll agree to install the Bambu Network plugin, and from here you'll want to log in and register. Next, I'll be adding my printer in the devices section, and up in the top left hand corner of the screen you can see a little plus sign and we say bind with pin code. You can get the pin code from the touchscreen on your device in the network section of the settings. And as long as your printer is connected to a Wi-Fi network, I told you earlier in the video, mine is being hotspotted from my phone, you'll see that you'll get a successful connection. And the first print that we'll walk through together is this snap latch case that I designed for the Bambu Lab filament swatch kit. It has 2 stacked inserts so you can hold every single sample chip from that kit, And I'll be providing these files on my Bambu Lab MakerWorld account. I'll put a link to that in the video description down below, so go check it out down there. I'll begin by importing the model for the insert, and in the top left hand corner you can see that I've got the Bambu Lab A1 selected as my printer, and I'll place that insert face down, and then I'll also press the sync button for the filament. This is going to sync the 4 filament options with whatever I have loaded into the AMS system. In the Objects tab, you can see the name of the model. I'm going to right click on that, and at the bottom of our options, we've got Change Filament. So I'm going to change it to position 2, or filament number 2, which is the Sparkle Gray. Then in the Global tab, we can take a quick browse through the various parameters inside of the 0.2mm standard profile for the A1. For now, I'm going to leave everything as is, and I'll just click on Slice Plate in the top right hand corner of the screen. You can see a sliced preview of this model. The first thing I notice is at the bottom we've got some unsupported overhangs that we are going to need to support. In the top left hand corner we can click on Prepare to bring us back to the model before we had sliced it, and here we can head on over to the Support Painting tool. I'll be selecting the paint bucket, and with that I'll be clicking on all of those surfaces that require support. Then in the support section of the print profile, I will be enabling the support and we'll be reslicing this plate. And you'll see that green looking material at the bottom of the model, and that will be our support material. We can use the slider on the right hand side of the screen to break our model down layer by layer and see what's going on the inside. Now obviously this is not an exhaustive guide on how to slice and prepare files, but if you've never used Bambu Studio before, hopefully it gives you a good idea of where you can find these tools and options. So now in the top right hand corner of the screen, we can click on Print Plate. This will give us a few options before sending the file to the printer, such as redoing the bed leveling, enabling the time-lapse, also running the flow dynamics calibration, which on the A1 I don't think is automated, so even having that box checked off might not do anything, and of course enabling the AMS system. Now if you click on the time-lapse, you'll get a warning. During the print head will move out of the way and pause very frequently, so this could cause print imperfections. I'll send that off to the A1, and on the screen you can see a preview of the model, and the printing will begin shortly. Now this is a single color print, so the AMS system will not be engaged in terms of switching filament, but you'll see it still feeding that Sparkle Gray Bambu Lab PLA into the print head. During the first print, everything was looking good. The first layer went down flawless, and there was no drama. With the print complete, you can lift the flex plate, give it a slight bend, and your print should pop off. Now in this case, all of the support material conveniently popped off, and most of it just stuck to the print bed itself, and the cleanup was minimal. All of the straight flat walls on this print looked very good. The sparkle filament also looks very attractive, and those slots where the filament chips will get inserted into also came out looking quite nice. Now I need 2 of these prints for my design, so right from the touchscreen you can click Print, and you'll see the file was saved locally. I'll select it on the touchscreen, and I'll deselect the bed leveling and the flow dynamics, and the time-lapse will be off as well, and then we can just hit Print. While that model's printing, we can jump back into Bambu Studio, and we can start preparing another part of this design. What I have here is the top half of the case, and you can faintly see my logo that I worked into the top surface of the case, and I want that logo to be a different color, so I'll use the color painting tool, which looks like a little bucket of paint. In order to color my logo, I feel like the most efficient way to do this will be with the fill tool. I can select the number 2 filament, which is Sparkle Gray. You'll see the main body of the lid is just PLA Basic White. And so we've got a nice contrast now between the gray logo and the white case. If you ever have 2 filaments loaded into your AMS that are different materials but the same color, over in the Objects tab on the left hand side, you can confirm what filament your object is set to using the numbers. Now for these snap latch case shells, I want to increase their strength a little bit, so in the strength section of the filament profile, I'll increase the wall loops to 3. Now the top shell layers was set to 5, but I felt like this was going to take a little bit too much extra time, so I reduced that to 4. I increased the wall density to 20%, and personally I like the triangle infill pattern. After slicing, I'll take a quick look at the preview using the slider on the right hand side. You can see the logo is gray at the bottom, so it looks like I've set it up correctly, and I'll send that off to the A1. Obviously, this is a very basic example of a multicolored part. Later in the video, we'll get into some examples with hundreds of color changes. But for now, with this very simple example, you can see the process in which the color change is done. The printhead moves over to the right hand side of the printer, and there's a bumper there which seems to release the filament. The remnants of the current color are purged, the new color is loaded, some of that is flushed to get rid of any mixing of the two colors. That purged material is wiped away, and then the printhead is further primed using the tower at the back left hand corner of the print bed. Now the rest of this model is just plain white, and again I'm using the Bambu Lab Basic White, and it turned out looking great. There is an advantage here to using the Bambu Lab filaments, because of course they've done their homework with the built-in presets, and you can expect top-notch quality without having to run any calibration for a new type of filament. The white filament is a little difficult to film and see all of the details, so we will of course be printing in some different colors, but I had to have the bottom half of my case match, so of course I printed that in white as well. The bottom half of this case is a single color print and had no logo on it, so I didn't go through the setup in the slicer, but it would have been the same as the sparkle gray insert that we first covered. Similarly, the latch and hinges are the same, they're just single colored prints, so I printed those in the sparkle gray to match the inserts. Now we can take a look at all of the parts together and we'll assemble our snap latch case. With everything on the table, you can see that I've already started inserting some of the filament chips into the one insert, and this other one here has not yet been populated. In the printable files that I've linked to in the video description down below, you'll also find an optional little pick here that you can print. I printed mine in orange, and if you orient all of the swatches with the hole facing up, you can use it to easily pull those swatches out of the insert. If for some reason any of them ever get really stuck, they're also accessible from the bottom, and you can use your finger to just simply push them out. When you're done with the pick tool, it's intended to be stored in the cutout in the insert on the left hand side. Assembling the case shell is very easy. As you guys have seen, there are just two halves, the top of which was the one with the logo, and the bottom does not have a logo. There are quite a few variations of these cases floating around out there. I designed this version here to have a single latch at the front. The latch and the hinges at the back all use these 1/8 inch diameter roll pins to secure everything in place. On the Maker World page for this model, I'll include all of the specs for these roll pins and some links to where you can find them. The pins get inserted from the right hand side, and then they'll press fit into the hole on the left hand side. The hinges at the back go through the exact same process. The roll pins for the hinges are much shorter, and there are 4 of these pins in total. They get inserted from the outside towards the inside, and to press all of these pins in place, you can use something like a vise. You're pressing the pins into plastic, so it really doesn't take much pressure to do this. If you don't own a vise, you could probably even use a set of channel locks. And if you don't own a set of channel locks, you could likely support the one side and very carefully tap them in place with a hammer. Once all the pins are in place, the assembly of the shell is complete. I'm just going to go back here and insert the rest of the filament swatches into the second holder, and I'll try and maintain some logical gradient here of the colors. The two inserts can be stacked and stored on top of one another. You'll see there's grooves where they kind of interlock, and those inserts can now be put inside of the snap latch case and shut. I've designed the case so the latch locks very tight, not likely to ever come out, and I've never had a problem with those parts breaking. You can shake the case around and you'll see that none of the filament chips fall out. The last feature that I've built into this kit is the ability to remove the filament chips and place them inside of these slots on the underside of the lid. The lid will hold up to 8 swatches, so you can plan out your color palette for your next amazing print. I'm very pleased with how this project turned out using the Bambu Lab A1, and again, you can find a link to this down in the video description below. Now we can move on to printing other interesting models from other designers, and I'm going to be finding those on the Bambu Lab Maker World website. This is where I shared the previous model that I just showed you, and you can find other incredible free to download models from other talented designers. I found this really nice looking jet engine clock. If you click on the green download or print button, you can directly download the 3MF. And don't forget to like, boost, or rate models that you find on MakerWorld, as it encourages people to continue to participate. This is what the 3MF file looks like after I open it in Bambu Lab Studio. In the top left hand corner, you can see that it's set up right now for a P1S. So I'll switch that over to the A1. When you do this, you'll likely be prompted to choose to keep or revert some of the print settings. In this example, you can also see that the designer decided to use multiple plates in a single 3MF project, and you can switch between those plates by clicking on them using the menu on the left hand side. But you can also set the active plate by directly double clicking on it in the 3D model window if you want to do it that way. You'll also notice that the filament colors are matching whatever the designer had going on with his P1S, so I'm going to resync that to my connected machine, which was of course the A1, and you'll see all of my active filament types and colors get imported from my AMS system, and they'll be assigned to the bodies inside of the project. And I'll start with this spiral cone looking object here, and I'm going to change the filament colors using the object list on the left hand side, and we'll get that printed on the A1 immediately. And the first thing I notice is that the white spiral pattern is not looking so white. It looks a little bit baby blue, so clearly some of the white was still mixing with the blue filament, and I think I would have to probably adjust some of the filament flushing settings. This would of course result in more wasted filament, but I'd imagine you would get a sharper transition between the blue and white. But we'll move on to a different part here. Now, I'm not a jet turbine expert, but I'll just call it the body or shroud. And this one will be interesting to me because it takes up most of the build plate, so we can see how well the A1 does with laying down the first layer across most of this build plate, and then monitoring as the print goes on that none of this part lifts or curls off of the build plate during the print. And in this case, it was a very successful print. There was no lifting. The first layer went down absolutely perfect, and those round surfaces look fantastic. Transition to orange is really sharp. Although in these round feet, there still is a little bit of color bleed going from orange to gray, and you can see the gray is a little discolored, but it's not something I think you'll really notice, so I'm not going to reprint that part. Next, I've got the turbine blades. These are mostly white until we get to the end, and you've got those orange tips. So we'll see that transition again from a lighter color to a darker color, which I anticipate won't be as much of an issue as going from a darker color to a lighter color. And it seems like I'm right, because if you look at the top center of this model here, you can see where we had to transition back to white. You'll see some of that orange bleed in the center. And the bottom of this part also has a lot of support material, so this was a good one to test the supports. In this case, they were pretty stuck on there. I did have to use a pair of needle nose pliers to get out those supports at the bottom, but they did eventually come out. And the final thing printed in this project here were the numbers. And you can see that there are some razor thin sections in these numbers. However, they still managed to somehow print. The only number that I had an issue with was the number 1. It had an extremely thin section that needed to be supported, and it was barely hanging onto the model itself, so it tore off at no fault of the printer. That's just the design. Despite losing the one small feature of that part, I was able to successfully glue the numbers to the turbine blades. The fit between all of the parts was very good, and I just used some super glue for some of the smaller parts and then some hot glue for larger parts, such as the clock mechanism. And if you guys are looking to replicate this project, I'll link to the original designer down in the video description below. And I believe he's got links to the clock mechanism parts, although I do believe his source for the parts was somewhere in Europe. So I'll also put my own link to the clock movement that I used in North America. The only slightly tricky part to this whole assembly was this part here where I was attaching the second hand. The second hand itself didn't really fit all that well into the cone, and I did have to trim away a little bit of plastic with a knife, and the glue also wasn't sticking that great. And you have to be really careful not to press too hard to bend that second hand. I did still manage to get it all together, and it does function, it works, and it keeps time quite well. The clock movement that I sourced is silent, so you don't get that tick, 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 which I personally find annoying. And I think it would make a really cool conversation piece on your desk or perhaps your mantle. If I were to print it again, I'd probably choose some more neutral colors, but overall, I really like the design, so go check that out. Again, link in the video description, and pass a like on to that designer. For the next print, I grabbed this pencil holder design from MakerWorld, and one of the reasons that I picked this is that it can be printed in vase mode. I'm going to use the Open in Bambu Studio button directly on the MakerWorld website, and you'll see that it launches Bambu Studio and opens the model. I'll print the base first. Now, you'll notice there are no color changes in this model here, but one of the reasons I've been increasingly using vase mode prints to test printers is that I feel like it's a good way of highlighting any sort of deficiencies with the part cooling fans. The walls will only be one layer thick, and as you're very quickly adding hot material on top of the subsequent single layer that's already probably warm, if the part cooling fans are not up to par, you'll likely get a lot of warping in the part. And in this case here, the part came out looking excellent, so I'm pretty confident that the part cooling fans on the A1 are doing a nice job. Before moving on to the organizer part of the print, I'll switch over the solid white filament to the Bambu Lab Marble White PLA. Switching over filament is really easy. You can just push the orange button to release the tension on the AMS Lite, pull the old filament out, feed the new one in, and just like when we originally loaded in our first rolls of filament, the AMS system will take over and draw in the right amount of filament. And this part in Marble White PLA looks great. Those single layer walls are really smooth and uniform. I don't really notice any print defects or artifacts. Now, Marble White PLA does tend to hide them quite well, but I checked that part over very thoroughly and it looked really nice. Now, before moving on to parts with lots of color changes, I did need to print a poop bucket. If you're not already aware, all of those little pieces of purged filament are referred to as poop in the Bambu community, and we've got a bucket here to capture that will go under the purge wiper on the left-hand side. And on this bucket, the straight walls look absolutely excellent, but I did notice a slight color change halfway through the print. The bottom half is more matte, and that's likely because those layers have more time to cool, so we could fix that with a minimum layer time setting. If all of the layers can cool at the same rate, I think that's going to make the color look more uniform. Next, we can jump into some examples here where we can dive further into some of the settings and features of the Bambu Studio Slicer. So again, I've got a model from MakerWorld. I'll select Open in Bambu Studio. We'll launch the studio with the 3MF already loaded up. I'm going to take this model and I'm going to scale it up to 200%. And again, when loading these 3MF files, the original filament list from that designer is loaded into the project. So I'll resync the AMS and you'll see what colors I have in there right now. The model automatically gets updated and I'm not really happy with these colors. Now what I could do is I could physically switch things around in the AMS system to try and match up the colors to something that I'm happy with. The other thing you might be tempted to do is trying to recolor the model here directly in Bambu Studio, but you'll see that this is a single body, so I can't just easily select individual bodies and change those colors. So you could also use the paint bucket tool, and I could select my different filaments, and I could perhaps try and use the fill or the triangle tool and try and individually select all of those faces, but that's also very painful and time consuming. So rather than do that, I'm going to revert those changes, and I'll show you my approach to the color change for this model in a moment. But first we'll address the supports. So I'm going to paint on some supports that are needed for this model here, whether it's color changes or supports. If I do have to manually paint them on, I do typically prefer to use the paint bucket tool where possible. If that's taking too long, I'll fall back to using the circle or sphere tool, and again, just manually paint on all of those supports that I think will be required to successfully print this model. After getting these supports sorted out, you can see that I sliced the model, and there are quite a few more color changes in this model here compared to what we've done previously. You can see that in the summary in the top right hand corner, the total number of changes is 262. And you can see all of the other statistics related to how much filament you're using for the model, the support, flush material, the tower, and then of course the total. So right now I want to focus on the fact that we've got about 116 grams of flush material and about 213 grams used total. And I want to show you one strategy that you can use here to put some of that flushed material to good use. So you can actually import another model and head on to the flush options when you click on that third model, and you can select to flush into objects infill and select flush into object, and also select flush into object support. You can also access those same options by right-clicking on the model name in the objects window on the left-hand side. But what this does is allocate some of that flushed material from what I like to call my primary model into this secondary model. And you're going to get the same sort of color banding pattern that you would in the tower in the back left-hand corner of the bed. But you can see that we've reduced some of the flush material from about 116 grams to 114 grams. The total amount of filament hasn't really changed because these models aren't taller than our primary model. And the more of these little models we add, the more we chip away at the flushed wasted material. Now these flushed models are pretty small and insignificant, so the impact on the amount of flushed waste material is also rather insignificant. If we import a larger model and do the same thing, you can see in this example here, when I go to slice it, there is a bigger impact on the amount of flush material. So we've reduced that to 96 grams. But the one thing to note here is that this secondary model is taller than our primary. So our actual total amount has increased from 216 grams to 234 grams. Any material higher in the secondary model than the primary model is of course going to increase the total amount of filament used. So if you are looking to just get a rough model just for fun out of your flushed material, try and reduce the height of it to at least match or be lower than your primary model. You can see this in the demonstration here. After I reduced the height of that tiger, we're getting back down closer to the original number of the total amount of material used, while again chipping away at the flush material, while at least getting a tiger model with some funny looking stripes. I ended up sending the file to the printer without that tiger, and now we'll address our color change dilemma. To recolor the model without physically changing the locations of the spools or repainting the whole model, in the AMS section before printing, you can actually just swap out one color for another directly on the screen. So I swapped out white for orange, gray for white, orange for black, and black for sparkle gray. In my opinion, this was by far the most efficient way to do the color change in this particular scenario. But of course, if you guys have a better way to do it, as I'm not yet a Bambu Lab AMS expert, I'd love to hear your feedback in the comment section down below. The print was successfully completed after almost 300 filament changes to achieve this Toyota Supra model. There were some really small details like those side mirrors that I was surprised came out looking so good, but there were also some details in this print that didn't look so great. You can see on the tires, there was a really steep overhang where the tires were first supported on the print bed, and that led to some stringing. And I think scaling up the model 200% didn't really work so well with the facets on the window that make up the curved surface. So I feel like the model is a little more to blame for that than the printer itself. There were also quite a few blobs of filament that I had to clean up. Overall, I think this is going to be the weakest example that you'll see in this video. Sticking with the car theme, I wanted another interesting multicolor print, so I went with this Brembo caliper business card holder. In this 3MF project, you can see that the model was only painted 2 colors, and I want to utilize all 4 colors in my AMS. Now, unlike the previous Toyota Supra example, I am going to be individually painting all of the faces using the paint bucket tool. And the reason that I'm doing it this way is because the model is not already painted, so I kind of have to do it, but also the model is made up of a lot less faces, so it is more manageable. When I was done painting, the sliced result looked something like this here, and you can see that it's going to take about 23 hours to finish. It's going to use 412 grams of filament, and 263 of those are going to be flushed out. The AMS Lite is going to have to perform about 548 filament changes to accomplish this. Now that's a lot of time and material for one object, so I do want to show you another strategy for more efficiently using your print time as well as that flush material. And that strategy is to simply multiply the exact same object within the same build plate or print. If I print 2 of these business card holders at the same time, you can see that the print time has only increased marginally. So now it's 1 day, 2 hours and 40 minutes. And if you divide that by the two models, that's about 13.5 hours per model. And we've got roughly the same number of filament changes. So you can see it's the filament changes that's taking up most of the print time. And by adding more of the same model, we're increasing our efficiency. We can also now divide out the flushed amount of filament per model, so it's a more efficient use of the flush material as well. But this all does come at the sacrifice of using more total material. By adding 2 more instances of the same model and then slicing it again, we get a total print time of 1 day 10 hours, which reduces our per model print time to 8.5 hours. The 250 grams of flush material can also be divided out by 4, which is around 62-ish grams of filament per model. So if you're running a print farm or you do happen to need multiples of the same multicolored part, always print those identical models together to save on time and flushed material. In my case, I only needed 1 for personal use and for the purpose of this video, so I didn't print 4 and I just patiently waited for this single piece here. But when it flawlessly finished, I was extremely impressed that there were over 500 filament changes in this model, and I didn't encounter a single issue. In my opinion, that's a lot of opportunity for something to go wrong when you're doing this dance of retracting, cutting, purging the various colors. So I've got to say, despite the amount of time that it took, I was extremely impressed. On top of that, the part itself looks really nice as well. The color changes were sharp, and I couldn't find any signs of ghosting or ringing around any of those indentations or text. Now that I've got a business card holder, the next logical thing to do would be to print some business cards. There's a parametric model on MakerWorld that I'll link to in the video description down below, where you can create your own customized business cards. The one thing I couldn't do in that editor was to add my own logo. So you can see down in the build plate that I've added my logo as a separate STL file, which I've created myself. Now I've added the 2 different styles of business cards into the project, and I'm going to recolor this one here. Similar to the business card holder, I'm going to be using the paint feature with the paint bucket tool, and I'm going to have to individually select all of those faces. After that, I can take my logo and I can center it within the circle of this business card design. And once I have it in a position I like on the left-hand side of the screen, in the object list, I can select both the business card and my logo. I can right-click and then merge those two. They'll be grouped together in an assembly, and as far as I can tell when slicing the model, they should be treated like a single body. And one thing I noticed after slicing these models here is that the text, which is very small and very fine, didn't entirely show up in the slice preview. There were gaps and portions missing. Obviously this didn't look good and I didn't want to send it to the printer like this. So taking a look at our print settings, we can fix this by making a change in the quality tab. So if you scroll down to the wall generator, it was set to classic and we're going to set that now to Arachne. I just wanted to point this out. If you're seeing similar things in some of your models where small details are missing, check out that setting and see if it fixes your problem, because it did for this text. On the A1, you can also switch to a smaller 0.2mm nozzle if you want to do some really small fine details, but in this case the text still came out looking very good using the 0.4mm nozzle with that Arachne setting. Of course, it would look even better with the aforementioned 0.2mm nozzle, but for the purpose of what we're doing here with this example, it's readable, and for now I'm not doing enough models with super small details that would warrant a nozzle change. Lately I've been seeing a lot of Hueforge prints on social media, and now that I have an AMS system, I wanted to try one for myself. I got this model off of MakerWorld as well, and for some reason when I resynced my AMS in Bambu Studio, it messed up the color scheme on this project. But since the color changes are separated into these layer height ranges instead of individual faces on the model, we can actually just change those layer height ranges to the filament color that we want. Right-clicking on the range won't bring up the filament color option as it normally would with individual bodies, and it took me a long time to figure out that you can just left click on the range, so select the range, and then use your keyboard and use the numbers on your keypad 1, 2, 3, 4 to switch those ranges to the corresponding filament in positions 1, 2, 3, or 4 in your AMS system. I couldn't really find clear instructions for that anywhere, so if you come across this, hopefully that saves you some time. The print itself came out looking extremely striking. This is my first Hueforge print, and I love the fact that you can get this 2.5D multicolored art with only 3 filament changes in this whole print. And that's because there's no mixing of colors on the same layer, it's just 4 different colors at 4 different height ranges. Now normally I'd probably cut the video here, but I'm enjoying this AMS system so much that I want to do a few more prints. And I'm going to load in some non-Bambu Lab branded filament, and when I put that in there, because there's no RFID tag, you'll see it show up as a question mark, but we can manually edit the filament, and we can select the material type was just PLA, I've labeled it as generic, and we can also change the color. So I'm going to load in some light blue, and that's how we can get it to appear here as light blue PLA on the AMS screen. And when we sync that in Bambu Lab Studio, it'll also just show up as generic PLA in that light blue color. If you're using a new filament, I would recommend going through some sort of calibration or tuning to get the best values for the dynamic pressure control. In this case, I neglected to do that, and the light blue color mostly turned out looking pretty good, except for around the bear's tail. That's where it's most noticeable, but throughout the head and body, you do also see some other strange artifacts that are not at all visible with the Bambu branded filament down in the cloud section where we've got the marble PLA. So this is a perfect example of why it's a good idea to do some of that calibration and tuning when using a new brand of filament. Despite those imperfections, the model itself is really cute, and I decided to print another design from the same creator on MakerWorld. Again, I'm going to link to these in the video description down below because I like them so much. And this one consisted of multiple parts that required some assembly, but it's this balloon that I printed in gold, which I thought was going to be the most challenging part for the printer because you can see how small the base is, and I figured there was a good chance that was going to get knocked off the build plate, but it didn't. I put the assembly together with some hot glue, and these two models complement each other so nicely. I get so many positive comments on these when people see them in person. Lastly, if you remember from the beginning of the video, included with my A1 combo kit was the boat model kit, and it's got that little wind up outboard motor. So I printed this hollow speedboat, which uses almost the full Z height of the machine, and there were no issues of Z banding or weird artifacts as the gantry made its way to the top. The frame and the motion system in the Z axis seems rock solid. The designer of this model also did a fantastic job with the fit of the motor within the boat. Plus I actually tested it and it floats and it moves, so bonus points for that. I would highly recommend if you get the boat kit, go download that model, link in the description down below. Overall, my experience with the A1 has been extremely positive. However, I did have a few difficulties while working with it, and I'll get through those first. So the first thing was the inability of this A1 to connect to my Wi-Fi network. And earlier in the video, I explained that it's looking for a 2.4 gigahertz network, Wi-Fi network, and I have a Google Nest Home Wi-Fi network, and it switches between 2.4 and 5 gigahertz depending on the device that's connected to. But for some reason, this thing just won't connect, and I have to hotspot it with my phone in order to get a connection to it. The second thing that I struggled a little bit with on this printer here was getting it set up with the Bambu Lab account, MakerWorld account, the app, registering, binding the device with the PIN code. Some of that didn't work out for me the first time around. I had to repeat the process a few times to try and get it to work. When I first scanned the QR code, when setting up the printer, it sent me to the Chinese version of the Bambu Lab website, and it was trying to get me to download the Chinese version of the app. I eventually found that I had to go to the Google Play Store to do that on my Android phone. If you're an Apple user, you'll probably have to go directly to the iOS or Apple Store, whatever that's called, and you'll have to get the Bambu Handy app from there. Don't use the QR code on the front of the machine during this process. And the third thing, after wrapping up all of the filming for this video, I'm obviously continuing to use this printer here, and I loaded in lots of different filaments. I've printed lots of things with this thing at this point, and I noticed that this machine seems to be a little more sensitive when using off-brand filaments. And so if you just select the generic PLA, let's say for example on the touchscreen, and you go to run that for, again, some off-brand filament, the results aren't so great sometimes, and you do have to spend some time calibrating and tuning for some of those new filaments. Whereas on other machines, I found that they're maybe a little more forgiving. You just throw in whatever PLA, you use generic PLA settings in your slicer, and away you go. Now the prints will come out okay looking on other printers, or in this one, again, you have to do some tuning and some calibration. But the thing is that when you do put the time in to get it right and get all those settings dialed in, the results are far better than other printers where I was saying you just kind of throw the filament in and go. So it really is one of these situations where you get out what you put in, and I would highly recommend that you tune and calibrate for new filaments. Otherwise, if you're using filaments that have built-in presets in the touchscreen or in the Bambu Studio Slicer, such as eSun or Polymaker, you can really tell that Bambu Lab spent a lot of time dialing in the settings for those particular filaments, because the results are incredible and you do get equal quality to what you would see from a Bambu Lab branded filament. Beyond that, I was very impressed with the reliability of the AMS Lite system. You saw in the video that I had some prints there that had hundreds of filament changes in a single print. And again, to date, I haven't had a single clog, jam, or issue at all with the AMS Lite system after, at this point, doing thousands of filament changes. So I'm very impressed with that reliability despite the complexity of the process. I also appreciate that the printer and the slicer are overall pretty easy to use. Now, 3D printing still requires a lot of learning and effort on the part of the user. It's pretty hard to get away from that at this point in time, but you can also tell that Bambu Lab is trying their best to improve and build on the documentation and the ease of use for the learning experience for a beginner. In terms of print quality, I felt like 95% of the prints coming off this thing were of exceptional quality. The one thing to watch out for is that Bambu Lab is trying to push you to use the Maker World website, which is great because there's a huge resource there in terms of 3D models and 3MF project files. But the thing that you have to watch out for with the 3MF project files is that you're downloading somebody else's settings. And so in some cases, you do want to use those settings because of course the designer set those settings in the project file, and that should be what works best for that design. However, this is not always the case, and those settings may also be specific to the X1 or the P1 series printers. And if you're using a different one like the A1, the settings might not work that great for you. And if you don't know what you're doing, it might leave you with the impression that the machine itself is not printing nicely, when that's not the case. It's just the settings that you've imported from those 3MF files, so be aware of that. Overall, I think Bambu Lab is a company that tries to very thoughtfully design their printers and their equipment, their software, etc. There's a lot less oversights and inconveniences that I found with this printer than I have seen with some other brands. And despite Bambu Lab being a fairly young company, I feel like they're doing a very good job with putting out very polished looking and completed printers. Not something that's going to be a project for you to finish or deal with. They've only been around for a few years, but I feel like a few years ago when I was reviewing printers, I started to get the sense that a lot of the big brands that had most of the market share were getting a little bit complacent and lazy with their designs. You only had very few options that you could buy for a desktop printer, other than of course building something yourself. When these guys came around with I think it was the X1 series, which was first, it was game changing, and it forced a lot of other players in the market to step up their game and compete. And that drove a lot of innovation in the 3D printing market, at least for the desktop series printers. So even if you're not a Bambu Lab fan, I think we can say thank you to the brand for pushing the other companies to do better and come out with nicer machines. So that's it for this video. Big thank you to Bambu Lab for sending me the A1, and a big thank you for you guys sticking around to this point, right to the end. I know these videos can get pretty long sometimes, but I try to be as thorough as possible, bringing you guys the best content that I possibly can. If you guys appreciate that, please click on the subscribe button and visit my website, embracemaking.com. I've got lots more new content to come. Thanks for watching.